Morning, this is your Stat Sensei, Mr. Spensei, and this is classwork 3.7 contingency tables, or 3A.7 contingency tables, and this will be scenarios 4 through 6. So, according to the American Pet Products Manufacturers Association, National Pet Owners Survey, 39% of the households own at least one dog. That sounds important. And 34% of the households own at least one cat. Assume 68% own a dog or cat. By the way, that is a really important word. So not only am I going to highlight it, the word or is important because that tells me addition. So or is super important. So this tells me addition. All right. And they want to know what's the probability that they have both. Now it doesn't say that, but that's what we want to know. Probability of both. Well, to do that, we need the general addition formula. All right. Well, the general addition formula is probability of A union. Oh, I'll write it over here. Probability of A union B equals the probability of A plus the probability of B minus the probability of A and B. This is the probability of both. And that's what the question is supposed to be asking for. So this is supposed to be both. This is the word or, and that's what told me I needed to use this formula. Now, A union B, I don't really see how that applies to this. I am going to write it one more time. A union B equals the probability of A plus the probability of B minus the probability of A and B. But we're not working with that. We're working with dogs and cats. So since we're working with dogs and cats, I'm going to use D for dogs and C for cats because I think that'll make more sense. Probability of dog union cat equals the probability of dog plus the probability of cat minus the probability of dog and cat. Well, what was the probability of dog? Probability of dog was 0.39 plus what was the probability of cat? 0.34. So we're going to say this is our dogs. And we're going to say this right here is our cats. We don't know what this is, the probability of dog and cat. That's what we're trying to find out. But we do know that 60% own or, which that means that goes in this category. So this is going to be 0.64 because or is addition or union. All right. Or, please note that down. Or is plus, which is the same as union. And notice it has that symbol. Okay. So that means 0.64 equals, let's add up those two values. 0.39 plus 0.34 equals 0.73. And I'm going to go ahead and just copy this over here. I'm not changing anything. Probability 0.64 equals 0.73 minus the probability of dog and cat. I'm going to subtract 0.73 from both sides. This goes away, and I end up with negative 0.09 equals oh, this is not 604. This is a 60. I'm so sorry, guys. That should have been 60%. So this is a 60. That means this is 0.13. So negative 0.13 equals negative probability of dog and cat. Because they're both negative, I can just change the signs. and we find out the probability of a dog and a cat is 0.73. So our final answer is probability of a dog and cat or both is 0.13. And that's our final answer. All right, creating a table. Once again, we need to read this looking for the two variables that mix. Kodiak bears typically have two baby bears called cubs. When there are two cubs, the mother bear always feeds the older bear until it has its fill, and then she feeds the younger cub. That sounds fair. This results in an unequal chance of survival for the two cubs. Suppose that the older cub has a 95% chance of survival. So there's our first number. Older cub, 95% chance of survival. If the older cub survives, the younger cub has a 60% chance. Here's a if, that's a key word. So that's a condition. And if the older cub does not survive, again, there's a condition. The younger cub has an 80%. So there's our third number. Okay, create a table. So it looks like we're talking about survival. And it looks like we're older cub survival, our variable, our, older cub survival. Now I'm going to put L and D, lives or dies. And we have younger cub survival. Lives or dies. Okay, we need to find the one number that's associated with only one variable. Well, let's look at, because is it going to be, it can only be either associated with one of these. Suppose the older cub has a 95% chance of survival. Well, when I read that, the very first thing I read is, you know what? It doesn't mention the younger cub at all. This only mentions the older cub. So this is going to be our upper variable. This variable up here is going to be older cub survival. That 95% is going to be written right here. And this means I'm going to write, if that's the older cub survival, so we're going to write older lives. And over here, I'm going to write older dies. Well, if that's the case, then we know this is going to be younger lives and younger dies. Well, if this is 0.95, I can put a 1 here, and this is going to be 1 minus 0.95, which is 0.05. Remember, we're going to bring these numbers up, but we have to write them small. So this is 0.95. And this is 0.05. And all we did was just bring the numbers up. We didn't even really think about it. We just did that. Well, we've done the 95%, so we can mark it out. Now, the next one says, if the older cub survives, the younger cub has a 60% chance of survival. Okay? And by the way, I get, if the older cub survives, the younger cub has a 60%. Older lives, younger lives, that's 0.60. So that gets written here, and this is 1 minus 0.60. So let's multiply those out. 0.95 times 0.60, and we get 0.57. And 0.95 parentheses 1 minus 0.6. This is 0.38. Let's add these two values together to make sure that they add up to one whole. Add up to 0.95. Sure enough, to add up to 0.95, that's looking pretty good. This plus this equals this. So we've taken care of the 60%. Now, if the older cub does not survive, the younger cub has a 80% chance of survival. So the older dies, younger lives is 0.80. and this will be 1 minus 0.80 because we need the complement. So multiplying these two, 0.5 times 0.8 is 0.4, and that's 0.05 times 0.8 is going to be, having trouble. 0.05 times 0.8 is 0.04. Apologize for that. Then we have 0.05 parentheses 1 minus 0.8, close them, and we get 0.01. I add this plus this, and I do get 0.05, so that's looking good. Now I can add straight across. So when I add straight across, this becomes 0.61. I add these across, and this becomes 0.39. These add up to one whole, so this is looking pretty good. So in this case, there's a 57% chance both live. There's about a 1% chance both die because the older dies, younger dies. Okay? There's a 39% chance that the younger dies, uh, uh, and there's about a 61% chance that the younger lives. So there you go. That's the way it all kind of breaks out. So the next one, the Air Force received 40% of its parachutes from Company C1 and the rest from Company C2. Okay, so we have two companies and we have a value here. The probability a parachute will fail to open is 0.025 or 0.002, depending on whether it comes from C1 or C2. Create a table for the situation. So the probability a parachute will fail to open is 0.0025 if it comes from C1. And by the way, that it doesn't say that, but depending on whether, and that's where it says depends, that's my conditional word. So if it comes from C1, there's a 0.025% chance it'll fail if it comes from C2. Well, these are based on an if because it says depend. Instead of using if, they use depend. So these are conditional probabilities. So this is the only one that's set on one particular value. So that means that is my starting point. Well, we know this is one whole. We know this is going to be 0.40 because this is my starting point. And what is it? It's C1. Okay, company one. And by the way, what are our variables? Our variables appear to be company, which is C1 or C2, and then the parachute opens, does not open. So those are my variables. So we have C1. If that's C1, this is going to be C2. Company one, company two. 1 minus 0.40 gives me 0.60. I'm going to write these numbers really small. 0.40, 0.40. This is going to be 0.60. This is also 0.60. Now, opens, fails to open, and we've taken care of the 40%. The probability parachute will fail to open, so we're dealing with fail to open, is 0.025 respectively. So 0.0025 goes here, and I need to write that small. 0.0025, and this is going to be 1 minus 0.0025. So 0.4 parentheses 1 minus 0.025 is 0.3. 0.4 times 1 minus 0.0025, 0.399. And 0.4 parenthesis 0.0025 is 0.001. I add these two values up and they add up to 0.40, so that's looking pretty good. Now, the next one says there's a 0.002 chance depending on whether it comes from C2. So failed to open. Once again, we're looking at failed to open from C2. So this is going to be 0.002, and this is going to be 1 minus 0.002. So 0.6 times parenthesis 1 minus 0.002 is 0.5988. And 0.6 times 0.002 is 0.0012. This plus this equals this. Now I need to add up this way. When I add up these two values, I get 0.9978. So about a 99.8% chance that it opens. And when I add these up, I end up getting 0.0022. So very small percentage chance that it doesn't open, and this plus this equals to this. And by the way, I should have said this multiple times. These two can swap locations. The most important one is this first one. So these two can swap locations. Once again, this is the most important important. These two could swap locations and you would still get exactly the right answer. Okay? Well, appreciate you watching and I look forward to seeing you on the next one. Thank you.